Hello, welcome to this lecture on sensor and transducer in mechatronics. Myself, Lovepreet Singh, Assistant Professor, School of Mechanical Engineering, Golgotia University. In today's lecture, we will discuss about basic of the sensors and transducers and their uses in the mechatronic field. As in the last lecture, we have discussed about the basics of mechatronics and their components. And out of all the components, the sensor and transducer are the basics requirements for any mechatronic system to work. It works like a eye of a human beings. The objective for the today's lecture to study the different types of sensors and transducers and their uses and the sensors, uses of the sensors in a mechatronic system. A mechatronic system basically has a two major components for study. One is measurement of physical parameter using simple network type measurement system. Second is the control of measured physical parameters. So these are the major components for study for mechatronics. One is measurement part and second is the control of the measurement value. What is the physical parameters which we can control. So this diagram shows the network type measurement system. In this network type system, there is input signal that is measured value, that is physical parameters. Maybe it's length or width or height or uh, voltage. And then there is a sensor and transducer. This input signal is fed to sensor and transducer. Then this sensor and transducer process this data, and then transducer data transduce the data to analog to digital. Means there is analog and to digital converter is there. Then there is microcontroller signal processing system is there. Then there is a network display that is linked, that is display to the network, whether it's a display or it further process to the next input variable. So this is the plant or process, sensor and transducer, CPU, communication card. These are the node closed locations. Then there is sensor bus, that is communication between the computer system and the sensor. Then there is a computer system. Then there is communication link. Then this sensor bus is connected to transducer, CPU, and communication card, and then plant or process. So it measures the physical quantity, then it converts the proportional change in physical phenomena such as electrical, mechanical, and magnetic. A transducer outputs usually in terms of change in electrical parameters like resistance, inductance, capacitance, voltage, and current. It includes the sensor and transducers or transducer which receives energy from the environment and the system parameters, so it changes to produce an analog signal. This is real world. So in the real world, there is physical parameters such as temperature, pressure, and speed. There is primary transducer, that is sensor. Then this sensor sends this physical parameters. Then if this sensor, there is converter analog to digital converter is there that convert this change this physical parameters to whatever the output required for secondary transducer. Then this data is sent to secondary transducer. Then there is change in electrical signal, that is output. Then this signal is converted into further to some output voltage signal, that is value for measurement control. And this is how this sensor technology works. Means first is the physical world, the physical parameters, that is temperature, pressure, speed, and length. This is a primary transducer that sends this physical world. Then uh, there is a change in that quantity to another quantity. Then means that physical parameter is converted into voltage or any another parameters. Then this secondary parameter is processed in the secondary transducer here. Then there is change in electrical signal output. On this change in electrical signal output is measured using the measurement control system, which gives a deflection value or value on the screen. So this is a sensing mechanism which works behind the sensor and transducer. So there is broadly classified as transducers classified according to fundamental principle of change, that is RLC, resistance, inductance and capacitance. Then there is physical primary or secondary transducers, then analog or digital transducers, then active and passive transducers. So according to physical principle of change, that is resistance, inductance and capacitance, that is electrical parameters RLC. Other classification is primary, secondary transducers, then the analog and digital transducers, then active and passive transducers. These are general classifications for transducers. So the first type of transducer is a resistive transducer, that is a change in force and displacement cause change in resistance. That is potentiometric transducer types are linear, rotary and helix. This is a linear transducer, this is rotary transducer, this is helix transducer. We will discuss further detail about in the next slide. Next is the strain gauge. When there is change in force that cause change in resistance. So the strain gauge types are flat. This is flat type. Helical. This is helical strain gauge. This is fall type. So how this strain gauge system measurement system works? This works on the Wheatstone bridge arrangement that convert the change in resistance into voltage. This is Wheatstone bridge, and this is amplifier circuit. This is power supply. Here's power supply. There is a resistance that are connected in series with this amplifying circuit. So when there is change in the resistance, then this strain gauge moves. Next is the structure of strain gauge. The majority of strain gauge are foil type, available in wide choice of shapes and styles to suit a variety of application. They consist of pattern of resistive foil, which are mounted in backing material. This is the end lobe. This is just one structure of shape gauge. This is active grid length. This one is active grid length. This is end lobe. This is solder circuits. They operate on the principle that as a foil is subject to stress, the resistance of the foil changes in a defined way. Next is the working of strain gauge. As a Wheatstone bridge circuit is the basic principle for this strain gauge. So if there is change in a resistance proportional to applied strain and measured with Wheatstone bridge method. So this is the strain gauge. In the strain gauge, this is the circuit diagram for that. This is the resistance which are connected in series with this circuit. Is there is change in resistance that is applied proportional to applied strain, that then this change in resistance is measured using this Wheatstone bridge circuit. The sensitivity of strain gauge is described in terms of characteristics called gauge factor. This is defined as unit change in resistance per unit change of length. That is K is equal to unit change in length resistance delta R upon R. That is unit change in resistance divided by unit change in length, that is delta L upon L. The gauge factor is related to Poisson's ratio mu by K is equal to 1 plus 2 mu. Next is the type of strain gauge. The strain gauges are based on principle of working, that is mechanical, electrical, piezoelectric, based on construction, that is foil strain gauge, semiconductor strain gauge, photoelectric strain gauge, based on mounting where they are applied bonded strain gauge, unbonded strain gauge. We will discuss further about these types of strain gauge in the next slide. Next is inductive transducer, that is LVDT, linear variable differential transducer. That is change in force, displacement cause, change in voltage. The main parts are primary coil. This is primary coil. This is secondary. This is secondary coil. This is also secondary coil, and this is movable coil. When there is a movable coil is there, then there is change in inductance that is measured using inductive this system. As there is this is movable iron core, this is secondary coil, there is also secondary coil 2, this is primary coil, this is voltage uh, power source. So when there is a movable this movable coil moves here, so there is change in inductance. The difference between these inductance is measured using this system. So the difference of this change in inductance is measured, and then we can measure the value of total change. So this diagram shows the amplitude absolute output voltage. There is a relation between LVDT characteristics, that is the differential output voltage, and amplitude absolute output. This is left movement from null. This type of curve is there, and when there is right movement, this type of curve is there. On another side, this is the LVDT characteristics with absolute output voltage. So at the zero side, this is zero, this is null point. On the right movement, this moves toward this direction, that is left direction. Then on the left movement, this moves to right direction. Next is Hall effect transducer. It consists of a current carrying metallic plate, that is a magnetic field perpendicular to the plate, and then transfers voltage output. This is Hall effect transducer. This is the direction of magnetic field, and this is magnetic field direction. This is the magnetic force on negative charge. This is magnetic force on the positive side. This is electric force due to build up positive charges. This is the direction of current flow, and so this difference in the inductance is measured using this circuit, and this is direction of current flow. This is a capacitive transducer. It consists of parallel separated metallic plate. Then there is a dielectric filling. This is parallel separated magnetic field, magnetic plates, that is metallic plates. And this is the dielectric filling, that is the dielectric fluid. This is on this side there is a positive charge plate is there. On this side there is a negative charge plate. So when there is change in measured value, then this the inductance, there is capacitance change that is measured using this circuit. Next is the piezoelectric crystals. The piezoelectric materials, quartz, barium, rock salt, etc. If it's subjected to force that stretch or compress it, an electrical charge is produced on one of its surface, and hence an opposite charge is also induced on it. This is piezoelectric material. When there is no force, there is no charge is produced. When there is force is there, so the compression force is working here. So some charge is produced or induced in this system. This is diagram for a capacitive tactile sensors. A piezoelectric material, that is quartz or a PVDF, is used for tactile sensor. When there is this is PVDF film. When the force is pressure is applied, this structure, this shape of the PVDF changes. So the voltage is applied on the using the AC input signal. So as the shape is changes, this input signal of that is passing through the voltage, that also changes. So this change in the a signal is measured here. So how does this pressure that is applied on this PVDF affect this output signal is measured. Next is photovoltaic transducer, that is convert the light energy into electrical energy directly at the atomic level. The material that exhibits these properties are known as photoelectric material, and this effect is called photoelectric effect. When there is as in this diagram, this is sun, the light radiations come from this, and from the this is contact material, that is reflective type, and there is anti-reflective coatings there. This is p-type material. The coating is provided with n-type material. This is contact material. So this when the p and n types are junction is made, there is a flow of voltage occurs. So this is power supply. So this is the circuit. When there is a uh, light radiation passes, so the p and n types junctions, there is some voltage is generated. That's enough to light the lamp. So how this photovoltaic transducers work? Next is photoresistive transducer. This the resistance of photoresistive material decreases with increase in light intensity, like photometric transducers. Next is photodiode. The incident light energy excite the holes electron pairs of the photodiode, allow it to flow current in a reverse bias mode. This is reverse bias mode. This is the reverse biasing here. Here the p-type material, p-n junction is there. This n-type material. So these graphs show the VI characteristics of photodiode. It phototransistors consist of light sensitivity, that is CV junctions, which base when the base is exposed to light energy, the base current flow proportional to light intensity. This is light energy, that is electromagnetic energy. This is base contact terminal, that is optional. There is a emitter connect terminal is there. When the photoelectric the electromagnetic energy is here, so that's complete the circuit. And this is the photo transistor without base lead. This is with base lead. Next is the flow sensors. These are the rotomotor, that is vertical floating type. This is a horizontal floating type. This is used. This type of sensor used to uh, measure the flow that is passing through the passage of the sensor. This in this there is liquid is flow in. There is a helical spring, and this is stepper. When the liquid is flow in, this stepper is pushed by liquid force, and this helical spring moves to toward this direction. And then there is a LVDT secondary winding is there. There is primary windings there. So some using this liquid force, this plate is pushed like in the right direction. So there is change in that voltage pass, as primary winding is giving us the voltage, and then this secondary on the secondary winding, the voltage passes through this core is measured. So using this liquid flow sensors, we can measure this voltage, and this from this voltage we can estimate how much the flow is passed through this opening. That is change in the thermal temperature cause change in shape, and change in bimetallic strip type transducer, and change in potential difference of thermocouple type. So this is thermal transducer. There the two materials are sandwiched. One is the low thermal expansion. This is upper material, and this is the high thermal expansion material. This is second. So on the different, this is second part is the bimetallic sensor strip. When there is a material B and this is material A, this the couple is formed, then the induced EMF is measured using this hot and cold junctions. This is the home assignment for all of you. You have to submit this assignment before the next class. These are the reference from where this all the image and this data is taken. Thank you.